Hi folks, we're going to take a look at this question from the assignment. So here we've got two gears that are turning. Okay, I didn't quite draw it quite as nicely as the sheet has it, but two gears that are turning. Okay, and they give us some information as to how the small one rotates. So they're telling us that the small one rotates 300 degrees. Okay, so say rotates that amount. And of course, as this one rotates, and I'll use a little demonstration here. Okay, so think of how gears work. Okay, as the small one rotates, so does the large one. Okay, now what you have to ask yourself is what is common. I think I'll just flip this around, it'll be easier. What is common when they rotate? Well, what's common is the distance that, say you pick one point on both of these, and as you rotate, as they rotate together, the distance that's traveled by a point on the edge is going to be the same whether you're on a small gear or on the large gear. Of course, the angle that's produced won't be as large on the big one as it is on the small one. Okay, so that's how we're going to solve this problem, is we're going to relate the distance that a point along the edge travels. But if we're talking about the distance of a point along the edge, we're essentially talking about the arc length. Okay, so say this represents the smaller gear. Okay, and it travels 300 degrees, so not quite all the way around. Okay, say to there, from there to there, 300 degrees. Okay, how can we calculate the distance that's traveled? Okay, one way is to consider it as a fraction of the circumference, but what we have is we have a formula for the arc length, which is exactly a measure of length along the edge of the circle that relates to the radius and the angle. But of course, that formula, which is A equals r theta, only applies for theta being given in radians. So the first thing I have to do is switch 300 degrees into radians, and I'm going to do that by setting up a ratio. Okay, so let's do that on the side. So I want to know how many radians is equivalent to 300 degrees, and I'm going to equate that to my ratio of pi radians to 180 degrees. Okay, so just remember when you're setting up your ratio is if you've got radians in the numerator, you have to start with pi in the numerator on the other side, and degrees in the denominator, you have to have your 180 in the denominator there. And so x is just equal to 300 pi over 180. I'm going to keep everything exact since I don't have a scientific calculator with me. All right, so let's simplify this here. So these things are both divisible. I'm going to guess 60 is the largest divisor. So 300 divided by 60 is 5 pi, and 180 divided by 60 is 3. And yeah, that's as simple as it's going to get. Okay, so this just gives us the angle. Okay, so 300 degrees is equivalent to 5 pi over 3 radians. So this is going to be our theta. All right, but let's now calculate A equals r theta. So my radius is 5. Okay, my angle is 5 pi over 3. So the arc length is going to be 25 pi over 3. Okay, but that's the distance that's traveled along the smaller gear. Now that same distance gets traveled along the larger gear. Okay, except I would expect my angle to be smaller. So now I'm going to solve the same problem. Okay, but instead of looking for the arc length, I already know what the arc length should be. I'm solving for the angle. So theta can be written as A over r, so just a rearrangement of this formula. And I know that the arc length is going to be 25 pi over 3, and I just have to divide that by my radius, which is 12, and that'll give me my angle in radians. Okay, so here 25 pi over 3 divided by 12 is the same as 25 pi times 3 times 12 is 36, and that is not you can't simplify that. Okay, now remember that I don't actually have to specify the units here, because when we're talking about an angle and we don't specify units, it's implied that we're talking about radians. Okay, so just a quick recap. First of all was this idea of realizing that when gears move, okay, while the angle that's turned with both gears is not the same, what will be the same is the distance that's encompassed around the edge of each of the gears. And so that's how we were able to solve the problem. So we were able to determine the arc length along the smaller gear because we had more information. And then once we had that arc length and with the radius of the larger gear, I was able to determine the angle of rotation. Okay, and by the way, if you take a look at this angle, 25 pi over 36 is clearly smaller than 5 pi over 3. Okay, but that's, that should be expected, given that this smaller wheel is going to turn a larger angle for the same amount of distance. Okay, that's it for this one.